In this video, I'm going to show you how to solve quadratic equations with a graph. And there are two methods that we can use to do this. One is with an intersection of graphs, and the other is with an x-intercept method. And I will be using the graphing calculator for both of these methods. So the first equation is x squared plus 4x equals 12. We want to solve it with a graph. Remember, you can solve these by hand using techniques like factoring, but the emphasis of this video is how to use a graph to come up with the solutions. So the first method is called the intersection method. And what I do for that is I take each side of this equation and I think of each one of those as a different graph. One graph is y equals x squared plus 4x, and you may know because of that's an x squared, this is going to be a parabola or a U-shaped graph. And the other one is y2 equals 12. And if you think about what it means to solve an equation, I'm trying to figure out what number or numbers do I plug in for x. So what inputs do I put in to make both of those y values 12? Because I want the y value on the left to be the same as the y value on the right. So if I'm going to use a graph to solve that, what I'm going to do is I'm going to come in here to my graphing calculator and I'm going to put in each equation, y equals x squared plus 4x, and then I'm going to put in y2 equals 12, and I'm going to take a look at the graph. Now what I see is the parabola there for the x squared plus 4x, but I don't see y2 equals 12. And the reason I don't see y2 equals 12 is that my window is set up to only show me x values from -10 to +10 and y values up to +10. So I need to go in here to my window and change the y value. So instead of going up to 10, let's say I go up to 15 so that I'll be able to see that line at y equals 12. So what I see is a parabola for the x squared plus 4x and the horizontal line for 12. And the solutions are actually going to be the x values. And the reason they're the x values is that the equation that I'm starting with only involves x. And it's going to be the x values at the points of intersection. So the solution is the x value of any point of intersection. And I can actually get my calculator to tell me what that is. So let me bring the calculator back. I'm going to use the intersect feature on my calculator. And the intersect feature in my calculator is underneath the calc menu, which is above trace. So I'm going to press second, trace, and that brings me into the calculate menu. And then I'm going to go down to intersect and press enter. It asks me three questions. The first one is this curve that the cursor is blinking on, is that one of the intersecting curves? And you can look up in the left-hand corner and see that that is. So I'm going to press enter. The second one is this horizontal line that the cursor is blinking on, is that the second curve? And again, if you check the equation up in the corner, you can say yes, it is. And then so I press enter and then I give it a guess, which means move the cursor kind of close to the point of intersection and press enter. And you can see that the intersection is the point 212. So since the solution is the x value of any point of intersection, one of my solutions here is 2. Now to get the other one, I need to go back and get this other point of intersection over here on the left. And to do that, I'm going to go into the calc menu, calculate. I want to go into intersect, number 5, press enter. Okay, first curve. Yes, this parabola, if I move the cursor along, that parabola is one of the first curves, so yes, press enter. Second curve, if I check the equation up in the corner, yes, that's the second intersecting curve, so I'll press enter there. Guess, if I want the one over here on the left, I need to move my cursor closer to the point on the left than the point on the right. So that's good enough. I'll press enter. And it tells me that that intersection is negative 612. And again, since the solution is the x value, this solution is negative 6. And you should notice that if I take these numbers and I put them into this equation, 2 squared plus 4 times 2 is 12, and negative 6 squared plus 4 times negative 6 is also 12. Now the other way that you can do these problems is with something called the x-intercept method, which kind of goes along the lines of the zero product property. So my equation that I have here is x squared plus 4x equals 12. Instead of putting those in as two separate equations, y1 and y2, before I put it in my calculator, I'm going to set this thing equal to 0. So I'll have x squared plus 4x minus 12 equals 0. And then what I'm looking for is what x values do I plug in here to make the value of this whole expression 0? Well, x values that you plug in to give you an output of 0, those are exactly on a graph points on the x-axis. Every point on the x-axis has an output of 0. So if I wanted to use the x-intercept method of solving this, I would put this in for y1 and just look for x-intercepts. So let me go back to my calculator. I'm going to clear out these original equations that I had, and I'm going to put in x squared plus 4x minus 12. And I'm going to graph that. You'll notice that I get a different parabola, but if this time on this parabola, because I have this equal to 0 in my equation, I'm going to look for x-intercepts. So on my graph, if I count to see where that parabola is hitting the x-intercept, and if I draw it over here by hand, looks like this x-intercept here is 2, and this x-intercept here is negative 6. Let me count here, negative 1, 2, 3, 4, 5, 6. Yes. So you'll notice that when I use the x-intercept method, I get the exact same solutions that I got up here using intersections. It's just a different graph and a different way of seeing the answer, but the solutions are the same. Okay, let's take a look at one more example. 6x squared equals 5x plus 4. If I use the intersection method, I'm going to put this in y1, the left side in y1, and the right side in y2. And then I'm going to ask my calculator to find the points of intersection. So coming back over here, I'm going to clear this out. So 6x squared in y1, and in y2, 5x plus 4. Let me press a graph here. So it looks like I have 2 points of intersection. I've got a line crossing through a parabola in 2 points. If I want my calculator to tell me the points of intersection, I'm going to go into Second Calc, above the Trace button. I'm going to select number 5, which is intersect, and answer these 3 questions. First curve, check the equation in the corner, press enter. Second curve, check the equation in the corner, press enter. When it says guess, move the cursor to the point that you want. In this case, I'm going to the point on the right. Then I press enter. And that looks like 1.3 repeating, which is 1 1/3. So one of my solutions here is x equals 1.3 repeating, which is 1 1/3 or 4/3. And then if I want the other solution, I have to go back into the calculate menu, select number 5, intersect, and do the same thing again. First curve, check the equation in the corner, press enter. Second curve, check the equation in the corner, press enter. And then guess, I need to move this cursor close to the other point of intersection there on the left and press enter. And that one looks like negative 0.5, which is negative 1/2. So it looks like I have two solutions, negative 1/2 and 4/3. If I wanted to use the x-intercept method, that would mean that I would set this thing equal to 0 first. So I have 6x squared equals 5x plus 4. If I make it equal to 0, I get 6x squared minus 5x minus 4 equals 0. And then that's what I put in my calculator into y1. So let me go up here and put 6x squared minus 5x minus 4. And I'm going to clear out what I have in y2 because I don't need that. And let's see, I know ahead of time that my solutions are negative 1/2, 4/3. So I'm going to change my window here so I can see those small values. I'm going to make my x values go from, say, negative 3 to 3, just so I can look at smaller x values. And let me press graph. So there's my parabola. And remember that when I'm using the x-intercept method, or the method where I make the equation equal to 0, I'm looking for where this graph crosses the x-axis. And I can certainly tell that this point on the left on my graph where it crosses the x-axis, that looks reasonable that that's the negative 1/2. And this one over here looks reasonable that it's 1 and a little bit more, but I can't really tell what that fraction is. So let me show you how to get x-intercepts using your calculator, if they're not nice integers. So just like I did intersect, I'm going to go in here to my calculator, but instead of finding intersections, what I'm finding are zeros. So I'm going to select number 2, 0, and I'm going to press enter. And it's going to ask me 3 questions again, but there are different 3 questions. So left bound means move the cursor to the left of what you're looking for. So I'm going to keep going here. Now I'm past the point on the left, so I'm going to press enter. And then it says right bound, so that means move my cursor a little bit to the right of the x-intercept that I'm looking for and press enter. And then it says guess, which means put it pretty close and give me a good guess. So I'm going to press enter there. And you'll see that it says the 0 is at x equals negative 0.5. Well, that's what we had before. But I'll just write it down again. And then for the other one, I have to do the same process again. I have to go through second, calculate. This time I'm finding a 0, so I'm going to press 2. Left bound, so that means I'm going to come over here to the x-intercept that I want, and I'm going to press enter just a little bit to the left of what I want. So I'm going to press enter there. Then it says right bound. That means move the cursor a little bit past where you want it. So a little bit to the right of where you want. And then guess means, well, put it as close as you can to the x-intercept and then press enter. And your calculator will tell you that that 0 is 1.3 repeating, which is the 4/3 that we had. I guess I didn't need to write this x equals again. Or 4/3. So if you want to look at one graph, you can use the x-intercept method. If you want to put 2 separate sides of the equation in, you can do that and look for points of intersection. Either way, the solutions are the x values that your calculator or that the graph gives you.